what's the probability of A to win or A to lose, right? Then more often than not, you're likely to say that it is 1 by 2, 1 by 2, right? Given that I have provided you no extra information. But if I particularly provide you the information that, it is between, I don't know, maybe between me and Roger Federer, right? So you'll immediately assign different probabilities to it, right? So extra information associated with the same stochastic process is likely to change the probabilities which are associated with it. Correct?
Yes,
So,
sir.
so similarly, every stochastic process has multiple probability measures which can be associated with that. Depending on your objective function of what you intend to achieve out of that stochastic process, you are supposed to use different probability measure depending on whatever is your objective, right? So we'll see why do we require a different probability measure for derivatives and how it is handy. Hopefully we'll be able to cover that part today. So I think so the coordinators, right, from FEBS, I think we are okay to start with the session, or are we expecting some more people to join?
Sir, actually, we have put so much, I mean, so many messages, but we didn't get. I think we can start it, sir.
Sure, no worries.
Yeah.
So let us start with the today's content. Okay, like I said, today is going to be build up on yesterday, and more likely it is going to be heavier than yesterday. So please be inquisitive. Okay, the more questions you ask, the better it is. And the reason why I was saying that you should have at least one doubt, right, from yesterday is because I think there's a small typo error in the assignment, maybe, right? I think in the second question, maybe one of the probabilities is mentioned as 1 by 5 comma 1 by 5, right? Q is equal to, right, which is kind of not possible. I think what it was meant was either it is 0.5 0.5, okay, or 1 by 2 1 by 2, okay. So again, this is a trivial thing, because anyways your whatever Python code you will write, it is going to be a parameterized one. So you are going to either take input of P from user or hard coded. In either case, you can quickly change it. So it should not be a big change in your as far as your code is concerned, but just some technical correctness. Okay. Let us get back to our today's topic. So today's topic is going to be we'll start with some. So like I said yesterday, right? All the things which we are going to see, we are going to see many concepts, right? We are going to see yesterday we saw the concept of random walk. Then today we are going to see the concept of Markov processes, okay? And we are going to see the concept of Martingale. Then we are going to later see the concept of binomial pricing tree. Okay, all of the concepts we are going to see keeping a coin toss in our center. Okay, so coin toss will be our central experiment around which we would be okay, we would be focused. So we'll continue with the same coin toss. Okay, so we start from here, we start from 0, right? With probability 1 by 2, we go to +1. With probability 1 minus 1, sorry, 1 by 2, we go to -1. From here, with probability 1 by 2, we go to +2. From here, we go to 0 with probability 1 by 2. From here, with probability 1 by
Sir,
2.
I can't
0.
see your screen.
Yeah, sorry. I think I forgot sharing the screen. Just give me a second. Let me share the screen. And let me know once you can see it. So sorry for that. Yeah, I hope you can see my screen.
Yes, sir.
Okay. So let's continue, right? So we have our random walk where we start with 0. So with probability half, we go plus or minus 1, and with probability half, we keep going, right, up and down, and so on and so forth, right? So Markov process is a stochastic process which is defined as this, okay? So probability of, okay, at xt plus 1, right, wherever it is supposed to go, given filtration t, okay, is given by probability of xt plus 1 wherever it was at xt, okay? So it is completely independent of where it was earlier, right? Now, to be able to write this statement, we need lots of basics, right? We need what is filtration and all of that, and which we have covered in our first session, right? So I hope everybody is able to recall what filtration means. It is the amount of information which is accumulated up till time t. That is why Markov process is defined as, the process where whatever happens, the probability of whatever happens in the next time step. So for example, we are standing here, time t is equal to 1. This is time t is equal to 0. And this is time t is equal to 2, right? So whatever happens, okay, so what does this mean, right? And again, since we are at an example, let us look at it, okay? So let us write down the probability. So probability of x2, okay, is equal to 2, given that x1, okay, is equal to 1, is given by, can someone tell me this? So given you are on this branch, right, what is probability of getting this, right? So this is 1 by 2, right? Similarly,
Probability of getting 1 into 1 by 2.
no, not required, because you're already at 1, right? You're already at 1. I'm asking you conditional probability. I'm providing the information that you're already at x equal to 1, okay? So anything what has happened until that, okay, for you, once you are at t is equal to 1, whatever has happened before and up to t equal to 1, that is deterministic now. That is not stochastic, correct? Because you already know that you are at 1. So from here, what happens, okay, it does not depend on what happened earlier, correct? Now, probability of x2 is equal to 0, given x1 was equal to 1, is equal to 1 by 2. Then probability of x2 is equal to 0, given x1 was equal to minus 1, okay, is also 1 by 2. And probability of x2 is equal to minus 2, given x1 was minus 1, is also 1 by 2. Okay. So all of these things do not depend upon what happened at x naught, okay, or what happened earlier and all of that, right? Once I have it what happens next only depends on where it was at this point in time. Okay? It does not depend upon what happened earlier. I hope everybody follows this definition of Markov process, if in case there is an issue. So the reason why this happens is, particularly for random walk or coin toss, we have already defined that, okay, what happens here, okay, is independent of what happens here. Okay, so these two probabilities are independent, correct? So this does not depend upon this. Okay, so in other words, Markov talks about that the stochastic process is independent of what happened earlier, and it just depends on what happened at t minus 1, whatever t we are talking about. Any questions so far as Markov process is concerned? I'll also show you now an example of what is not a Markov process, so that should clear a lot many more things. But any questions so far?
Clear, sir.
Yeah, so we are seeing all these things in discrete sense, but all of it absolutely holds in continuous sense as well. Okay, discrete I'm just showing so that it is easy to understand and explain and build intuition on, but everything holds as it is in continuous sense as well. So let us redo this. Just give me a second. Okay. Now let us redo this in terms of what is not a Markov process, right? Now consider a stochastic process like this. You start from 0, okay? With probability 1/2, you go to +1. With probability 1/2, you go to -1, okay? Now after you are here, what happens is from here, okay, so if you had +1, right? So this becomes P, okay? And if it was +1 with probability P, you go to 2, right? And with probability 1 minus P, you go to 0. Similarly, if you're at -1, okay, then you go down with probability P, okay, which gets you to -2, and up you go with probability 1 minus P. Okay, now let us see these things again. Okay, so what is the probability at, x2 is equal to 2, right? Given that x1 is equal to 1, right? So given that you were at 1, right, what is probability of getting 2? That is equal to P, right? Then probability of x2 is equal to 0 given x1, okay, was equal to 1. Okay, this is 1 minus P. Then probability of x2 is equal to 0 given x1, okay, was equal to -1. Okay, is 1 minus P, and probability of x2 is equal to -2 given x1 was equal to -1. Okay, this turns out to be P. Okay, so if I were to switch these probabilities, correct, to switch these probabilities, right, then what happens is this turns out to be, right, this turns out to be P, and this turns out to be 1 minus P, right? So right, whether you go to x2 equal to 0, right, from whether you're going from x1 equal to 1, right, or x1 equal to -1, okay, it depends. Okay, so your probabilities change completely whether you're trying to go to x2 equal to 0, from whether you're going it from x1 equal to 1 or x1 equal to -1, right? So thereby your probability of your outcome, okay, it depends upon where you're coming from, right? That is why this is not a Markov process. Okay, so this becomes Markov if P is equal to 1/2, and a special case of which we saw earlier, which is a random walk, right? Any questions so far? I hope no questions, right? Now let us look at a new concept, okay, or a different concept. Let us look at the concept of Martingale. Let us look at the concept of Martingale. Okay, so Martingale is a stochastic process which is defined as expectation of xt plus 1 given ft, okay, is equal to xt. Okay, so this is the definition of a martingale, right? I hope so. This looks simple, right? But note that there is a distinction between two. Okay, so here we are saying that probability of what happens from, so you're traveling from time t0 to capital T, correct? Like we saw yesterday in gambler's ruin. So when you are at a particular time, okay, so what happens next, okay, does not depend upon what has happened earlier, correct? It only depends upon where you are at time ti, correct? It, from here only, if you multiply the transition probabilities, you get whether you are going to go to I plus 1, or whether you are going to go to I minus 1, or I minus 1, or whether you are going to, I mean, in random walk, you cannot stay at I. So at the next step, you are going to go either here or here. So what is going to happen next depends only on where you are at currently. It does not depend on whether you came from this direction to here, or whether you came from this direction to here, okay, or from where you came from. Whereas as martingale is concerned, okay, expectation of wherever the stochastic process is going to go, right, under the information of where it is currently, okay, that is equal to xt. Okay, so now let us look at a random walk. Okay, let us go one step further and take one more step in the random walk. So this gives us 2, this gives us 0, this gives us 0, this gives us -2, right? And let us take one more step. 3, 1, 1/2, -1, 1/2, 1/2, -3. Okay, so let us say we are at time t is equal to 2, correct? So whatever has evolved until now, we write that as filtration ft. Okay, so what is expectation of x3 is equal to 3, okay, given that x1 or x2 was equal to 2. Can someone tell me this? I mean, this may not be intuitive to everyone. That is why I'm asking, okay, if you know how to evaluate this. Okay, the way to evaluate is, assume that you're present here, correct? Assume that you're present here. Okay, so from here, what all values does the random variable can take? The stochastic random variable, what all values can it take? Okay, so what is x? Correct. What is x3 given x2 is equal to 2? Okay, this random variable itself is 3 and 1. Correct. Now this is a random variable. So what is probabilities associated with it? Probability to take 3, okay, given you are at 2 is 1/2, right? And probability to take 1 given that you are at 2 is 1/2. Correct. So what is expectation? Okay, expectation is multiplication of xi's, okay, and p of xi's. Okay, so this is equal to sum product of, okay, or let me just remove this. This is equal to 1/2 times 3 plus 1/2 times 2, right? So what is this? 2. And what is this equal to? Is this equal to this? Right? This is equal to this. That is why we call, Okay, so that is one check. Okay, that's not all. For Martingale, what is supposed to happen is we said filtration FT. Filtration means whatever would have happened. It could have been 2, -2, or 0. For all these cases, it is supposed to match. Okay, so we'll check if it matches. We checked for only one case. Okay, let us check for other cases. So what is expectation of x3? Okay, now x3 equal to 1. Sorry, I think this was wrong, right? This was just supposed to be expectation. So what is expectation of x3, right? Given x2 is equal to add 0, right? Now you are on x2 is equal to 0, right? So what all values x3 can take? X3 can take the values of, so let us write out the random variable first. The values it can take, x2 equal to 0. Okay, the values it can take is -1, 1, right? These values. Okay, and that it can take with probabilities 1/2 and 1/2. Correct. So expectation of x3 given x2 is equal to 0. Okay, is given by some product of these two, which turns out to be 0. So this matches with this. Okay, now there is one more check that is left. So x3 given x2, okay, was -2, right? So this random variable takes values of -1, -3, and then if you take expectation of x3 given x2 equal to -2, okay, is again -2. So this equals this. Okay, any questions so far? Any questions on Martingale? So whether you keep moving ahead, forward, backward, go anywhere, okay, and at t+1, whatever is the expectation, that is equal to whatever was at xt. Okay, so this is the concept of Martingale. Okay, so any questions so far? This is important because this is going to answer the question which was asked right at the start of this call, right? What is the difference between probability measure P and Q, and why do we require Q? Okay, we are very shortly going to come to that point. So is there any question here? I think you can go on mute if you are not speaking. So, so let us proceed, right? Now let us look at, so can someone give me an example of a stochastic process which is a Martingale but not a Markov process? Okay, again, we want the examples in terms of the same thing which we have seen, right? In terms of a coin toss. Okay, now I want the participants to, think through this. I want them to give an example of a process which is a Martingale, but not so yeah, which is a Martingale, but not necessarily Markov. Or rather, you can give me an example which is a Markov, but not a Martingale. So that is, I think, easy to think through. Give example of a Markov, but not a Martingale. Okay, what should I change in this coin toss so that it is a Markov, but not a Martingale? Let me write it down. Can someone tell me what change should I make to this coin toss so that it continues to be Markov but not a Martingale? Hello? Are people there on call? Yeah, anyone?
Random walk, we can take the probabilities in different branches so that we can ensure that it is a Markov but not Martingale.
Sorry?
We can tweak the probabilities of, let's say we have the third layer, so probability of going from 2 to 3 can be, let's say, p, and from 2 to 1 is 1 minus p, and similarly we can tweak other probabilities as well and ensure that it is a Markov but not Martingale.
Right. So we can go for the generic example slightly later, but can you give me an example of probabilities which I can assign, right? So you're right, right? We can change the probabilities, right? So what should I change it to? Okay, instead of a generic P, can you give me a number?
Yeah, so essentially, let's say probability of going from 2 to 3 is 1 by 3,
Okay,
and
3 is 1 by 3.
2 to
Sorry,
1 is 2 by 3.
just give me a second. I think it malfunctioned. Okay, so 2 to 3 is 1 by 3. So this automatically becomes 2 by 3, right?
0
Now
to
what
1 we can take 2
now?
by 3.
Yeah, before that, right? Before that, what is this expectation now? Now expectation of x3 given x2 was equal to 2, right? What is this? This is equal to 3 into 1 by 3 plus 1 into 2 by 3. What does this turn out to be? 1 plus 2 by 3, 5 by 3. Okay, so this is no longer equal to this, so it is not a martingale. Even if you change for 1, it is sufficient, right? Because if this happens, then this statement does not hold. Correct? Because filtration ft means it is supposed to be true for all 3 cases. So even if it is not true for one case, this statement does not hold, and that's why it's not a martingale.
Yes.
Okay, so this is going to be martingale for how many set of probabilities? If I give you the same evolution, which is +1 -1, 2 0 -2, or 3 1 -1 and -3, for what set of probabilities is this going to be a martingale? I mean, how many probabilities? Okay, for different probabilities can it be a martingale? Can it be a martingale if this is 0.45 and this is 0.55?
I think it has to be 0.5 and 0.5.
Exactly. Now, where does that come from?
From the outcomes.
Exactly. So it only depends upon outcomes, correct? So these are different set of probabilities. Okay, now let us say you are at 2, okay, and you are going to 3 and 1. Okay, now the natural, so if you are using an unfair coin, okay, so if you are using an unfair coin, correct, then your probabilities are never going to be 0.5 0.5, correct? It means you already know upfront, okay, that probability of going from here to here, okay, is going to be whatever, different, right? 2/3, 1/3, whatever, right? But so this is going to be martingale only if these are the outcomes, correct? Then this will be a martingale only if these are the probabilities, which is 1 by 2 1 by 2. For any other probability, this will not be a martingale. Okay, So there is no value add of knowing what actually the coin is, right? If you're modeling this as a martingale or a fair, no, sorry, if you're modeling this as a martingale, right? So there is no value add of knowing, okay, what the actual probabilities are, correct? We'll look at a specific example, but I hope you understand this example, right? Now, now let us look at a different kind of example. Okay, so this motivation builds, okay, the thing which we tried to prove or tried to establish here is there are only one set of probabilities, okay, which depend upon outcome, okay, such that the process is a martingale, right? We have established this. Now let us change our game, okay, and do something else. Now let us say we are playing a game of probability. The game is such that you start from here, okay? You get 5 rupees, okay? If you get 5 rupees if something happens, right? So if omega 1 happens, you get 5 rupees, and you get 2 rupees if omega 2 happens, right? So what is the price which, and there is certain probability associated with it, okay? So let us say 2 by 3 here and 1 by 3 here, okay? So what is the cost of playing such a game? Can someone tell me?
The expected value of this.
Yes, so the expected value of this, which is 2 by 3 into 5, right, plus 1 by 3 into 2, right? So if somebody charges you lesser than this, okay, then there is arbitrage.
Yes.
If someone charges more than this, then also there is arbitrage, correct? There is only at this price that there is no arbitrage, correct? I hope everybody follows this.
Yeah.
Now let us consider a stock price, okay? It changes in context of stock price because, okay, if you're at time t is equal to t naught, okay, so you are at time t is equal to t naught, and let us say the stock price is 100, okay? So at time t is equal to t naught, you have already paid 100 rupees to play this game, correct? So here the outcomes were known, correct, and the probability is known, right? And we were finding the cost of playing that game. But in stock market, what's happening is you have already paid 100 rupees to play the game, okay? So the moment you buy the stock, right, you have already paid 100 rupees for it, okay? Now what is happening is, now we want to flip the question the other way around, okay? So what happens if there are only two possibilities, okay? The two possibilities are stock can go to 105, okay, or it can go to 102, okay? So what will happen in this case? Okay, what will happen is there is an arbitrage here, correct? It means once you buy it at 100, okay, under no possibility you're going to lose any money, correct? If you're not going to lose any money, then you're obviously going to play this game, correct? And if you're going to play this game, what is going to happen? Okay, this stock price will keep going up, okay, keep going up until what point? Hello? This will keep going up until what point? Okay, what is the upper limit that it can keep going up?
Until there are no buyers.
No, it has got nothing to do with buyers, right?
It keeps going up indefinitely.
Okay, so let it go indefinitely, okay?
Yeah.
So let us say the stock price is 110, okay? And there are only two future states possible, 105 and 102, okay? Is somebody going to play this game?
No, sir.
You'll not play this game, correct? Will you play this game if stock price is 106?
No.
No. So at until what point you can play this game?
105.
Up maximum up to 105. Okay.
Yeah.
Even at 105, you're going to be flat. Okay. If you're going to be flat or worse, you're not going to play the game, correct?
Right.
There's
so less
no
than 105. Below
correct.
105.
Yeah. So it has to be above 102. Okay. And below 105. Okay. Now let us try to find out the probabilities P, okay, for which it is a martingale. Okay. Given these same set of states, okay, given the same set of states, which is 105, 102, and 100, okay, let us try to find the probabilities P for which it is a martingale. Okay, what does that mean, right? So P into 105 plus 1 minus P into 102 is equal to 100. Okay, so what is this? 3P, correct, plus 102 is equal to 100. P is equal to minus 2 by 3. Okay. Can probabilities be negative?
Yeah. It doesn't matter.
Probabilities can't be negative, right?
I mean, actually, in probabilities, we don't worry about the sign, right? Whether it's positive or negative.
The probability can't be zero, right? What do you mean by probability less than zero? You have a coin toss. You can get heads or tails. Okay. What is meaning of probability equal to minus 2 by 3?
Impossible.
No. You cannot assign probability less than this, right?
Out of
I think
scope.
we started. No, not even out of scope. Out of scope means zero. Why are you assigning minus 2 by 3? Why can't you assign minus 5 by 8? Okay. Probability measure, which we had discussed in the first class, right? It is supposed to satisfy few conditions. The conditions are this. Probability of omega I has to be greater than or equal to 0. Probability of omega I has to be less than or equal to 1. And sum of probabilities over all omegas should be equal to 1. Right? So this does not satisfy this condition. If this does not satisfy this condition, what it means? Okay, it means that there is arbitrage. Okay, which we had concluded through a logical argument earlier also. I hope everybody's following this set of arguments.
So essentially, I had one doubt over here. So when we are considering this, are we not considering the time value of money as well?
We will consider it, okay, but not at this instant.
Okay.
Currently, we'll assume rate of interest is equal to 0. Okay.
Okay.
We'll come to time value of money when we are talking about futures and all. But I hope everybody understands this argument that if you are standing at 100, okay, and the possibilities that the stock can go to 105 or 102, then there does not exist a probability measure under which expectation of stock price is a martingale. So expectation of S, okay, under this probability measure, okay, is not or cannot be equal to S, okay. And without even going into arguments that this probability is negative and all, we already established that this condition leads to arbitrage, okay. And even after looking at solving for P and all, we see that this is not possible, right? That is why there exists no probability measure, okay, for which this stock price is a martingale. Note that we are not talking about natural or actual probabilities here, okay. We are talking about a hypothetical probability such that the expectation of the outcome under which is equal to the current price of the stock. And what is relation between this martingale measure, okay? So martingale measure probability, which is generally in literature it is called as Q, and natural measure P, okay? So these two are not connected at all. What is connected is what we studied yesterday, okay? So expectation under Q, okay, of dou Q by dou P of X is equal to expectation under Q of expectation under P of X. The expectations are related, but probabilities are not related. Okay. So, so that there is no arbitrage, okay, there has to exist a probability measure, different probability measure Q, the expectation under which of that stochastic process is a martingale, is the same thing, and that's why it's a martingale. Okay, so this is a very fundamental argument. This is called as, you can Google it up. Okay, so fundamental theorem of asset pricing, theorem of asset pricing, and all. Okay, so this states that there exists a unique probability measure, okay, under which the stochastic process, so unique probability measure under which the stochastic process is a martingale. Okay, if this is the case, then this implies that there is no arbitrage. If this does not exist, it means there is arbitrage. Okay, we can look at, we can Google this up. Okay, so fundamental theorem of asset pricing, PPT or PDF, okay, or PDF. Okay. So if you look at any standard material, okay, the reason why I don't share material is this. Okay. So the way they explain it is, right, is this, okay, there is state price density, okay, then you take probability measure, then you take expectation of that, okay, then you take there is state contingent probability, then you have a vector of asset state prices, then you have asset prices, then you take the expectation, okay, and then expectation under Q. So what happens is you keep getting into a lot of literature which you first need to understand before understanding the meaning of fundamental theorem of asset pricing. Okay, so if I share you this, your questions will start from, your first question is what is a state price density? Okay, how do you define it? Okay, then and there are a lot of other things. So Aerodebrew securities, complete markets. So see, there are three objects: state prices, density, risk neutral probabilities. So there are so many things, okay, which you need to build up to come up to a good rigorous mathematical framework which explains this. Okay, now the same example, same thing I have explained with a very simple lucid example. Okay, which is why, to back this up, if I share this material, you're going to find a disconnect between, because I have numerical examples and there you have lots of first background concepts, and then on top of that concepts you have built your final conclusion, right? I myself struggle to find a good such material which does not talk about. So if you see fundamental theorem of asset pricing here, right? Yesterday I tried to search a lot of it, but most of it they'll be writing it mathematics so much, with so much notations and mathematics, right? So we equip with SEM, arithmetry and all. So what happens is you stop losing intuition and you start going into abstract maths and all, right? And that's why you stop losing understanding the basic meaning of it. So you have a convex set of portfolios, self-financing portfolios, and this is exactly the point where you start getting lost. Okay, and this takes away the focus from the basic concept or intuition which we want to build, right? So we don't want this to happen, which is why I have taken simplistic examples and explaining the same thing but in a different way. Okay, if somebody finds a good material on fundamental theorem of asset pricing which does not use this notation, and maybe which uses a different example, right, please do share it on group. Okay, but this is what we have in terms of fundamental theorem of asset pricing. Okay, any questions so far? So if you take any course in MFEs and all of that, right, you will be largely going through these kind of rigorous mathematical proofs. You will not be going through so much of intuition based and so much of understanding based, right? You'll be going through all of these things, and then you will be, so even if you look at radon-Nicotium derivative, right? So if you look at radon-Nicotium derivative, right, and PDFs on that. So this is the language in which it is written. This is how it is written in a strict mathematical sense. Okay, and how do you switch from one probability measure to another probability measure? Okay, and so on and so forth. Okay, so you need to define what is a measurable stochastic process, and there are a lot of other mathematical background, okay, which you require to be. So if you look at radon-Nicotium derivative, it resides in the realm of mathematics. Okay, not necessarily being applied to only derivatives. That is why it is written with rigorousness of mathematics and not really with keeping QF in mind. Okay, a finite measure case, infinite probability measure case, and all. Okay, so it complicates a lot of things, and someone who is starting it, okay, feels overwhelmed by so many notations and all, and spends a lot of time first understanding the basics and notations. Okay, any questions so far? If you complete the assignments, okay, and whatever we have covered so far, you will definitely get the intuitive understanding of what we are discussing and all the basics of QF. On top of which, then you can go ahead and take up any book or any course, and you will not get confused or you will not get embroiled with the concepts themselves. And you can, on yourself, you can keep progressing ahead. Okay, the moment someone says it's a martingale, it means you understand what it means. Someone says Markov process, you understand what it means and what it doesn't mean also, which is equally important.
But what is the main difference between quantitative finance and financial engineering? Like,
No difference in that sense. Okay, in my opinion, quantitative finance, okay, see, there are different kinds of roles. Okay, I'll explain the roles. and then I can tell about the subtle difference between QF and FE. Okay, and again, this is in my opinion. Now, what all roles do you have? You have first role of a quant researcher. Okay, the job of that guy is to read research papers like this, whatever you would have. For example, pick one concept of this, understand this, okay, and simplify and make it to the stage which I have kind of brought, right? That in simple terms, this is what it means. Okay, then the second role you have is that of a quant developer. Okay, quant developer, performs the kind of code, the kind of assignment as a solution which all of you are doing, that is more from the quant developer side, right? Where you understand something what happens at the back end and you convert that into a code, right? So in my opinion, quant finance in itself is more inclined to this, FE is more inclined to this. Okay, so then you have a lot of other roles. Okay, so you have traders, and you have a validation analyst, okay, who checks these models and make sure the models are good and all of that. Okay, so FE is about development of financial engineering, right? So this is engineering, so you engineer new financial products. Okay, and this is kind of implementation of product in terms of a Python code base, building Python libraries which does pricing and all of that. In that sense, as you can understand, not everything has an analytical solution, which I said yesterday, right? In that case, you will require some simulations, certain generation of random numbers, and from there you need to arrive at certain results. Okay, that can be done by this guy. Okay, but establishing framework, understanding white papers, making them palatable and understandable so that it can be implemented by a developer is what is the job of this guy.
So if you can complete FRM certification, I think both will be covered, quant finance and financial engineering.
Not really, because FRM does not have stochastic calculus. Okay. So I have done FRM. FRM does not have any stochastic calculus at all.
So
It
somebody has
has
to do.
it has a lot of arguments. Okay, it has the same argument of Martingale, it has same argument of no-arbitrage, but it does not use stochastic process at all. It does not use Ito's lemma, stochastic process, and all of that, which is very fundamental for QA.
So FRM is inclined towards more towards financial engineering than quant finance.
Not really. It is inclined towards risk management part of it only.
So if somebody wants to cover both quant finance and financial engineering, would you say
So,
MFA?
no. So if you take any course, okay, generally it will have electives of which have overlapping electives as well. Okay, so if you are doing financial engineering, right, it will also have electives on computational finance. It will have electives on how to generate random numbers. Okay, how to reduce the variance reduction techniques. Okay, so you will have antithetic variance reduction techniques, and the other techniques. So this is largely in the computing side of it. Okay, but this is also as part of elective, it will be available in FE. I'm talking about all FE courses as far as foreign courses are concerned. Okay, or even if you do CQF, right, the first part of it will largely be focused on theory and academics and all of that, and second part of it will largely be focused on you can have a lot of coding and application in that sense, or ML, even ML, right? So it has a lot of that. So in terms of what is closer to, so you can take, for the sake of academics and studying and all of that, you can take FE and QF academically as synonymous. You're not going to lose out on anything even if you pick either of the course. Again, I'm talking about all foreign based courses. Then if you can't go to foreign and for whatever reasons, right, and if you want an equivalent certification, then the closest equivalent certification is CQF. FRM is good for purely risk management. CQF can give rise to both things, right? And both FE and QF also can give rise to both things. You have investing, okay, and risk management.
So if somebody wants to go towards trading or
Yes.
investment banking or hedge funds, CQ is
So
better.
yeah, so again you're getting confused. Okay, investment banks will largely require risk management. Okay, hedge funds will require investing. Okay, now Investings are also of two kinds or many kinds for that matter. Okay, investing itself can be classified. Let us go here. Okay, so you have quantitative finance course, correct? Then that gets divided into risk management and investing. Investing in itself is of three kinds. Okay, so you have fundamental investing. Okay, looking at financial statements, balance sheets, and all of that. Okay, and then coming up with a strategy. Correct. That is fundamental investing. Then you have technical analysis, and then you have quant. We will see some quant strategies, okay, as a part of our course. This suits you if you are from background of CA, CFA, and all of that. Okay. This I haven't seen an official course. This is generally covered as part of either MBA, okay, or at least some parts of at least one or two electives will be present in every certification, but not in FRM. It will definitely be present in maybe it is present in QF and all of that, just as part of one of the electives, just to give an introduction. But a lot of material is available online and you can learn it yourself as well.
But CFA is nowhere related to quant.
Not at all.
Okay.
I mean, again, it is related. CFA in itself has some parts of risk management also. It has VAR and all of that. Okay. But the final objective of CFA is, you do good equity research analysis, right? You can pick stocks, right? Do discounted cash flow valuation. Okay. Tell that based on the fundamentals, right?
Fundamentals,
Based
yeah.
on balance sheets and all of that, tell that which is an undervalued stock, overvalued stock, and all of that. Okay. So the likes of, this is my understanding, okay, the likes of Warren Buffett and all, okay, fall in this category. I've not studied technical analysis so much, so I'm not sure who is the idol here. Okay, I'm not sure, but in quant finance you can have the idols of, the Medallion Fund is a hedge fund, right, which uses only quant strategies. Okay. And a lot of things like Citadel and all of this, Jane Street, okay, they might be using, I don't know. This definitely does. He has this guy, James Simon, right? He has a book called Man Who Solved the Markets. Okay, so he talks a lot about strategies and all. Okay, now this being the case, risk management in itself is a big animal, right? But you will find risk management largely in banks, investment banks, because of their business model and because of their mandate. Okay, so they are subject to regulations and all of that. Hedge funds are not so much subjected to regulations. Okay, they don't have to show to regulators that they have enough capital and all of that. But risk management then is divided into four parts. You have market risk, you have credit risk, you have operational risk, okay, and then you have regulatory risk, and then of course there are many other risks, reputation risk and all of that. But this goes into derivatives, okay, and other securities. You have bonds, stocks, and you analyze the risk for them. This goes into someone can default, okay, someone can default on a loan, so probability of defaults and all of that. Okay, so counterparty credit risk. Operational risk has its own I have never worked on this, so I'm not sure, but I have learned in FRM that there are subtypes of it. Plus you have regulatory risk, so different regulations and regulatory reporting and all comes under this header. Okay, so this is a big picture of quant finance. Okay, this operates largely under P probability measure. All of this operates under Q probability measure. Okay, in terms of volume of jobs, right? Volume of jobs. Okay, you will find volume here. Okay, And in terms of value jobs, in terms of, you know, very high paying and small teams, okay, small teams and high payments or high salaries, you will find, and plus this is high risk as also. So this is high risk, this is low risk, and low compensations. Or, and again, I'm talking very roughly, okay, I'm talking only an average, there will always be exceptions. But so this is the nature of this, okay, and this is the nature of this, okay. I hope everybody's clear.
Yes, sir.
We can get back to our topics because we still have a lot of ground to cover. We'll introduce a concept of Brownian motion or Wiener process, and then we'll kind of end this. Okay. So if you would have seen yesterday's, I don't know how many of you got a chance to write a code and all of that, but let us plot a random walk. Okay, let us plot a random walk. If you simulate a random walk, you can definitely plot it, right? So here time t is equal to capital T, and I have divided into small partitions, okay, and at each instant, okay, so here I put, okay, let me do it this way. Can I get the backgrounds? Graph. Okay, now let me erase this, but get back to it. Right, so we have our graph. Okay, so we have this, right, and then we have these points, then we have these points, okay, and then we have time intervals. So we have this. So if you plot your random walk, right, what is happen is you will start from 0 at t equal to 0, at t equal to 1, maybe you will be here, okay, then maybe at 0, okay, then here -1, okay, then 0, then here, right, then here, then here, like this and so on, right? So your random walk will look like this, okay, and so on and so forth, right? So it will keep jiggling out, okay. So as you generate this random walk with, you know, as time t equals to, so if you have partitions here, right, and you have t equal to capital T here, you have partitions t1, t2, right, so that your partition, you have for your total space from 0 to t is divided in n parts. So, you know, t ti minus ti minus 1 is equal to capital T by n, right, for all I from 1 to n, right? So as you keep going smaller and smaller, right, you will see that this random walk resembles a Brownian motion, okay, and we'll see exactly what a Brownian motion is. But before that, we have one assignment question, okay. So please do make a note of this. Okay. The assignment question is essentially to simulate. Write it down here. So assignment or question number 1 for assignment 2, right? So assignment 2, question 1. The question is simulate and verify central limit theorem. Okay, so central limit theorem connects us from XYZ distribution to normal distribution. Okay, so I'll be more specific about what code to write. So first, it is supposed to be a Python code. Okay, second, okay, what you're supposed to do is take so you need so let me describe a trial. So every trial is going to be like this. In each trial, you're going to pick 40 random numbers. Okay, all from different distribution. Okay, by distribution, different distributions, or you can be so for example, random number 1, okay, comes from uniform distribution, okay, distributed between 0 and 1. Random number 2, okay, it can come from normal distribution distributed between 0 and 1. 3, geometric, okay. 4, Poisson, okay, and so on and so forth. Plus, after you're exhausted 4 5 of your random numbers, I mean in terms of distribution, right, you can revert back to, so for example, 5th, uniform, okay, but you can take a different distribution, right, between 2 to 5, right, and 6 can be normal, okay, between using mean as 7 and standard deviation as 8, something like that. Okay, so generate 40 different numbers in a particular trial. Okay, this is trial 1. Like this, you will generate few hundred trials, few thousand trials. Okay, so maybe you will have 1,000 trials. Okay, now for each trial, what you're supposed to do is for each trial, okay, calculate mean and sample variance. Okay, so I don't think this might be required. Variance might not be required. Just calculate sample mean. Okay, and okay, check the, or plot. Okay, plot the distribution of means. Okay, frequency distribution. It will look something like this. It should something look like this. Okay, so it should look something like this. Okay, then the next thing to do is, so let us say X bar represents mean of ith trial, correct? From that, you subtract the mean of all X bars. So you take X bar, okay, and then divide that by variance of all X bars, Xi bars, sample variance. Okay, and then plot this frequency distribution. Okay, so this should resemble normal with some mean and sigma, and this should resemble standard normal distribution. So I'm already giving you the answers, but formulating it in terms of a Python code is what I'm expecting. I hope there is no question on this. If you require any more details, right, you can even Google it up, in the sense that, you know, central limit theorem, you can read it up more about it on Wikipedia. Okay. So you have central limit theorem, and you know, okay, so this is what it is supposed to be and all of that. Okay, so I hope you should be able to do this. But central limit theorem is the connecting link between, it's a connecting link between a random walk to Brownian motion. Okay, so we are now going to move to Brownian motion. But before that, any questions? Any questions on the assignment question? Anything unclear?
Sir, can you please explain again the 40 random numbers you have asked us to take this
Right.
one uniform, this part?
Right. So you have to generate 40 random numbers, correct? So in other words, it is realizations of random numbers, right? So all I'm suggesting is not in the same sequence, right? But you can use, each of you can use different random numbers generators and generate 40 different random numbers. Okay. So let me show it here. So let this be x1, x2, okay, and so on up to x40. Correct. So first is a uniform random number between 0 to 1. Okay. So let me say that this number is, let us say, okay, 0.6789 something something. Okay, this is first random number. Second random number, a normal distribution, you know, with mean 0 and variance 1, right? So this can be 1.6875, so on and so forth. Now x3 can be from another geometric distribution, Poisson distribution. So you can use anything, continuous, discrete, whatever distribution you want to use. So you will end up with different random numbers, right? And you can generate 40 such random numbers. Okay, so this I will call as trial 1, right? Then trial 2, using the same parameters and same distribution, I will regenerate a number. Okay, another number. In trial 3, I'll generate it again. Trial 4, I'll generate it again. Correct. I hope this clears the doubt.
Yes, sir. Thank you.
Okay. Any other question by anyone else? Vijay is there on call, right? Vijay, you're there? Or maybe someone from FEBS team, right? You can help me if you want to explicitly write it down. Then please try to make a note of this assignment so that this can be shared with students. Okay. So let's move to the next part. The next part is, I'll name this as, what did we cover here? We covered Markov, Martingale, and fundamental theorem of asset pricing. Slash, I'll keep this as Q1. Assignment. We'll just take an introduction of Brownian motion and we'll take a short 5-10 minutes breaks. So let us define a Brownian motion. Okay, I'll not rely on memory and I'll just use some reference of Wikipedia. Brownian motion. Okay, we will stick to the definition on Wikipedia. I don't want to be incorrect. Yeah, in many literature, it is also called as Wiener process, okay, and Brownian motion, which is exactly same, but it has 4 properties. Okay, we'll look at them one by one. A Wiener process is denoted by WT, okay, and it has following 4 properties. Property number 1, it says that W0 is equal to 0, right? So it starts from 0. Okay, first simple easy property, right? Then second is WT is almost surely continuous. Okay, so WT is continuous. Okay, then third is WT has independent increments. Okay, this is pretty much a reflection of Markov property, right? Something what happens now is not dependent on what has happened earlier. And you know, WT minus WS, okay, where S is less than T is normally distributed with mean 0, okay, and variance, okay, or variance of T minus S. Note that this is not the standard deviation, this is the variance, T minus S. Okay, we are going to look at these things in detail. Let me plot it. You start from 0, correct? You're going to start from here, and then it's going to be something like this and all of that. Now let us look at one thing at a time. Okay, so this is, it starts from 0, so W0 is equal to 0, which is okay. WT is continuous. Okay, can someone tell me if f of x is a function of x, okay, what is the mathematical condition for x to be continuous? I mean f of x to be continuous.
We can say that limit x tends to k for all k, limit for x tends to k plus and k minus should be equal to the functional value at k.
Correct. So f of x has a domain, right? Right. Let us say this is D, right? So as x traverses over all the domain, right, and as x tends to k, right, so f of x k plus should be equal to limit f of x k minus, right, f of x should be equal to f of k. Okay, this is what he just said. So this is true for a Wiener process. Okay, so Wiener process is continuous. Okay, we'll not go into technical details of what is almost surely and all for now. Okay, because that's not relevant to our discussion. but what it means is it is continuous. Okay. So when will it be continuous? So for example, can someone give me an example of a not continuous function?
Greatest integer function.
Yeah. So, or called as, we can take an example of step function, right? So if you start from here, right? Let us say step of x. Okay, step of x is defined as, okay, it will be between, I mean it, so as long as it is between, okay, between certain integers, it will take the one before that and all of that. For example, if it is 5.6, okay, then step x, if x is equal to 5.6, step x will be 5, right? If x equal to 0.9999, right, still step x will be equal to 0. Okay, so integer part up to that number, right, is what is the step x function. So it looks like this, right? So it is, okay, let me use this. So it is 0, okay, and then it jumps, then it jumps, then it jumps, right? So if you try to find the limit, okay, so if you go to just to the left of this point, which is, say this is an integer, let us say 2 or 3, right? So limit as x tends to 2, right, step x, right, where if it is 2 plus, this will be equal to 2, limit x tends to 2 minus step x, okay, will be equal to 1, and these don't match themselves. Okay, so that's why this is not a continuous function. Okay, which is not the case with the Wiener process. Okay, what we are saying is it is continuous. So wherever it is from, so like I said, you have a random walk, right? And limiting case of a random walk as time t equals to delta t, okay, tends to 0. Limiting case of a random walk as delta t tends to 0, okay, is Brownian motion. Okay, so as you keep zooming in, right, you will always have whether it went up or down. Okay, so this is your random walk. Okay, so you went like this, 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 this. So everywhere, okay, there is a value. Okay, if you zoom only into this part, okay, you will still have some values within that. Okay, so this,
So
something like
usually it's continuous only, na? Like why we are discussing about, we discussed about non-continuous.
sorry. No, I was just explaining the concept of continuity to everyone. Okay, what it means to be continuous, what it not means to be continuous in rigorous
Right.
statistical sense. Not everybody might be aware as to how to check it mathematically, right? So I just discussed a precursor to that, and what I'm discussing now is the fact that why it is continuous. Okay, because yet you have not seen what a Wiener process is, right, or a Brownian motion. What I'm saying is you're defining Brownian motion as a limit of a random walk as delta t tends to 0, correct? And given that in every instant from t to t plus I, okay, there is something, okay, you would have moved either +1 or -1. Okay, so however you will keep zooming in, okay, you will always find something which is present. So that's why this is not discontinuous. Okay,
Right.
that's
No,
what
continuous is fine, sir. I want to know like why it's discontinuous or
what
not
is
continuous.
what is discontinuous.
No, like you are discussing about the function, asking for example of not continuous, right?
Yeah, so this is not continuous, right?
So how it's practically implemented?
No,
Or not?
I'm just explaining a concept of non-continuity. Okay,
Mhm.
in context of Brownian motion, nothing is not continuous. Everything is
Correct,
continuous.
correct. Yes, yeah.
So I'm just explaining that there are some mathematical functions which are continuous, some are which are not continuous. But in context of Brownian motion, we are talking about only continuous part of it.
Only
I
continuous.
mean,
Yeah, got it.
there is nothing like not continuous Brownian motion. Okay. So in Brownian motion or in whatever QF context, we are talking only about continuous processes. Okay. So that is about continuity, right? Then it has independent increments. Okay, what it means is, okay, so if I slice a particular part, okay, so if I were to observe a Brownian motion from here going ahead, right, it does not depend upon whether it came from here, okay, or whether this Brownian motion has gone like this and come at this point like this, whether it has gone like this and come at this point like this. Okay, it does not depend on that. Okay, so what happens after this point in time depends only on where it is at this point in time, correct? And it does not depend on how it reached there. Okay, and there is also a property of independent random numbers, right, which we will be using later. The property is this: if you take expectation of two random numbers, x and y, right, I mean x into y, where x and y both are independent, okay, then this expectation can be written as expectation of x into expectation of y. Okay, so this is a property which we will use later, but I'll just write it down for our noting down, right? So expectation of x into y for any two random variables, okay, which are independent, is given by expectation of x into expectation of y. We'll come back to this later. Okay, but mathematically this is how independence is defined. Okay, and you know, intuitionally this is what it means. Okay, this is the logical meaning of it. And finally, right, this is very defining characteristic of Wiener process. So because independent, continuous, and starting from zero, all these properties are satisfied by random walk also, right? But what is special about, you know, Brownian motion is this part. Okay, so Wt minus Ws, okay, is normally distributed with mean 0 and variance of t minus s. Okay, so let us pick any point as t. So this is, let us say, s, and this is point t. Okay, so if you were to re-simulate this Wiener process again and again, right, where you are starting from s at the same point, okay, the same point you're starting this Wiener process again and again, right? So it will take many paths like this, like this, like this, like this, right? Okay, and it will reach at many places, right, at x equal to t, right? So if you take a cross section of this, okay, and see the probability distribution of it, so this is normally distributed with mean 0, okay, and variance t minus s. Okay, so this is just a property of Wiener process. Okay, this is just the way I'm defining the process, right? Any questions so far? Any questions? So what we'll do is we'll just take a short 15 minutes break and then we'll continue from here. Okay, so let us meet back at 15 minutes, right? In 15 at 10:50, right? So let us meet back at 10:50. Okay, let's just take a short 10-15 minute break. Yeah, welcome back everyone. So let us continue with our session. I'll just, while everybody joins, right, I'll just revise what we have discussed so far. So Brownian motion has four characteristics: Brownian motion / Wiener process. So occasionally it is at some books it is denoted as BT, some books it is denoted as WT. So Brownian motion has four characteristics. It starts from 0, okay, W not equal to 0, W2 is continuous, right? And WT has independent increments, okay? Independent increments mean that, you know, what is going to happen, okay, in the next part, right, is independent of what has happened, okay? So what happens between this part to this part, between this part to, you know, between this part to this part, so what happens here does not affect what happens here, okay? And okay, WT minus WS, where S is less than T, okay, is normally distributed with mean 0 and variance of T minus S, okay? So this is just the basic properties of Brownian motion. Any questions here? So we will see a concept, okay? We'll see some small things, okay? Okay. So can someone tell me what is expectation of a Wiener process, WT? What is expectation of a Wiener process, WT?
Zero.
Oh yeah, but why is it 0? Because notice that we have yet not defined what WT is, right? We have just defined that WT minus WS. We have not defined WT and its probability distribution, right? So what is the random variable WT? I mean, what is its distribution?
Normal distribution.
With mean
0.
and variance? Variance?
T.
Sorry,
T.
why T?
Because we are taking SS0, maybe something like that.
Yes, you're absolutely right, right? So expectation of, you know, WT can be written as, okay, you can write it as expectation of, you know, WT minus WS, okay, where S is equal to 0. So it becomes expectation of WT minus W0, right? And we have seen that W0 is 0. So expectation of WT, okay. So expectation of WT minus W0, okay, where WT minus W0 is normally distributed with mean 0, comma T minus 0, which is equal to 0, comma T. Okay, that is why WT, okay, is normally distributed with mean 0 and T. That is why expectation of WT is equal to 0. So it's not trivial, okay? So we need to be sure of what's happening. That is one. So how do you define variance of a random variable? Variance of random variable X is defined as, can someone refresh me on this?
Expectation of x squared minus expectation of x squared.
Minus expectation of x squared. Okay. So this is the simplified version of it. The general version is expectation of, x minus expectation of x whole squared, right? So this simplifies to this eventually. But okay, so let us see this. Then what is variance of WT? Okay, it is expectation of WT squared of WT, right? Minus expectation of WT squared, correct? We have seen that this part is 0. So this part becomes 0, right? So we are left with expectation of W squared T, right? And what is expectation of W squared T? It is normally distributed, right? W is normally distributed with mean 0, okay, and variance capital T, right? So variance of WT is simply T. I hope everybody follows this. Any questions so far? Now let us see third property. Okay. Can someone help me with solving, what is expectation of WT, okay, into WS, where S is greater, where T is greater than S. Any thoughts, any ideas?
Expectation of WT into expectation of WS.
Yes. No, these are not independent, right? I think let me plot it, okay, and then let us see what is WT and WS. A very good attempt, but unfortunately it's not in line with our definitions. Okay, so this, okay, is our Wiener process. This is any point S, correct? So this is S. So this is point T, right? And this is WS, okay, and this is okay. So WT minus WS, okay, is independent of WS minus W0, okay. But if you consider this full process WT, okay, this is not independent of WS. I hope you see this. Okay.
Yeah.
Because WT also includes WS, correct? Only this part is independent. This is independent of this, but this whole part is not independent of this. Okay. So we will take a cue from what you just said, right? We require independence, right? But what is independent? Okay. So how can I write WT, right? I can write WT as, can I write WT as WS plus WT minus WS? Can I do this? I'm allowed to do this, right? Because if we simplify, WS cancels out and we end up with WT, correct? Now let us simplify this. Expectation of WS squared, okay, plus WS into WT minus WS. correct? This is expectation of WS squared plus expectation of WS into WT minus WS, correct? This part, now this is independent of this. This is independent of this, correct? That is why we can split it up. So this we can write as WS into WT minus WS, right? And we have seen what this is and what this is. Both of them are 0. So this is 0, this is 0, this part is 0, right? So we are left with this, which is expectation of WS squared, right? Which is equal to S. Okay. So expectation of WT times WS, where S is less than T, is given as S. What happens if S is greater than T? Can someone tell?
T.
Yep. So if I have to write generically, then expectation of WT into WS is equal to what? How do I write it generically if you don't know whether which is greater, T or S? If you don't know that, what is that expectation then?
Minimum of T and S.
Yes, absolutely right. Okay. So I will write this down because we'll require it later. Expectation of WS, WT, sorry, into WT is equal to minimum of S comma T, whatever may be the case. Okay. I hope everybody has followed these things so far. Now these are the preliminaries which we require for proving a very important result. Okay. And the result is called as, you know, what is quadratic variation of a Brownian motion? Okay. No, yeah. So even beyond quadratic, okay. So we are just trying to establish that what is dw square. Okay. So we are trying to establish what is dw square. Okay. And let us see how we can do that. Okay. What we'll do is we'll take, okay, we have a timeline, right, between 0 to small t. Okay. And further we are dividing it into smaller parts. Okay. So a random part, okay, there. Okay. We are going to call that as this as tj plus 1 and this as tj. Okay. Now, okay, let us define q pi. Okay. So where pi, okay, pi is equal to these partitions. Okay. Pi are partitions, which is, I mean, these time intervals, right? T0, T1, T2. Okay. So on up to Tn, or capital T, small t, what we have. Okay. So let me mathematically define Q pi. Okay, so Q pi is sum of squares of the increments tj plus 1 minus wtj, okay, and square of this for j equal to 0 to n minus 1. Does anybody have any confusion with respect to this definition? All I'm doing
Sir,
is
what is Q here?
I'm just defining something as Q, right? Just like we say let x is equal to something, right? So just like that, I say that there is something called as Q. Okay, Q is defined as squared of your Wiener processes over discrete time intervals and take sum of that until capital T. Okay, so here I have W2, here I have W1, right? So my Wiener process is going to move like this, something over this period. Okay, what I will do is I will take this, I will take this. Okay, so these are two random points. I'll take difference between these two. Okay, whatever is the Wiener value, and I take square of that, and I add it up for all these partitions. That is Q. Okay, any question here? Okay, then what we do is we take expectation of Q pi. So expectation of Q pi is expectation of summations of j equal to 0 to n minus 1 wt j plus 1 minus wtj squared, right? So what we can do is we can bring this expectation in. So this will be summation of j equal to 0 to n minus 1 expectation of wtj plus 1 minus wtj whole squared. Any doubt so far? No doubts? So now let us try to solve this. Summation of j equal to 0 to n minus 1. Okay, expectation of, okay, let us square it up. Okay, wtj plus 1 whole squared, okay, minus 2 times wtj plus 1 into wtj, right, plus wtj square. Then we take this expectation and apply it independently, right? We apply it for each of these terms, right? So summation of j is equal to 0 to n minus 1. Expectation of wtj plus 1 whole squared, right, minus 2 times of expectation of wtj plus 1 times wtj plus expectation of wtj square, right? Now please tell me what these values are one by one. Okay, sum of j equal to 0 to n minus 1. What is this? What is expectation of a Wiener squared of a Wiener process?
The variable.
Yes, I mean the variance is this itself, right? So this is tj plus 1, correct? What is minus this?
0.
0.
TJ.
Yeah. TJ. Why TJ?
Because we have derived it earlier that it is minimum of S and T.
Okay. Just give me a minute, okay? Someone is at the door. Just give me a minute. Let me come back. Okay. So just now we had seen that it is minimum of, T and S, and minimum here is TJ. And what is this?
TJ.
Yeah, this simply is TJ, correct? So this is equal to sum of j equal to 0 n minus 1, okay, tj plus 1 plus tj. Okay. So can someone tell me what is this? Sorry, there is a mistake here. This is minus. Okay. Can someone tell me what is this?
Tn minus T0.
Yes. Where T0 is 0, right? You started from 0, right? So this essentially is just T. Correct? So if you have the squared of increments, okay, squared of increments adding up to T, right? So your dw squared, okay, will be equal to dt. Okay, your squared of increments add up to T, so your d squared of increments will be equal to dt under only one condition. Okay, if your variance of q pi is equal to 0. Okay, now proving that variance of q pi is equal to 0 is an even more rigorous, mathematical thing. So we'll not, I mean, it is beyond the scope of our course, right? But if you're interested in how this works, right, you can refer to a book by Steve Shreve, right, which is about stochastic calculus for finance. Okay. So this brings us to a very important derivation, that dw squared is equal to dt. This is known as quadratic variation of Brownian motion. Okay. Any questions here? Any questions here? Any questions?
Sir, any usefulness of this, like the
Yes.
quadratic variation?
Yes. This is, so you must have heard it many times over and over again. We have Ito's calculus, correct? So far up to class 12 engineering, right? We must have heard about Riemann integrals, okay, and calculus of deterministic functions. Correct. We are building the fundamentals of by this result, okay, of quadratic variation. We are building the fundamentals of of calculus for probabilistic functions. Correct? We are saying that fundamentally this is different from that. Okay, this is not same as that. Okay, we'll see a refresher of our regular calculus. We'll see Ito calculus and all of that. Okay, but when we reach at that point in time, we'll require this result. So we'll keep this handy or this in our mind. Okay, when we reach there. Now, you will ask, can we calculate quadratic variation for a normal function, right? So try to calculate it. Okay, so try to calculate quadratic variation for a continuous function. Okay, let us say 2t square. Okay, can someone tell me the algorithm to calculate quadratic variation for a simple function called 2t square?
You basically
We're
have to
going to follow.
differentiate and
No,
then integrate.
no, not required. I mean, we are doing it via code, right? Via Python, right? So the way you will do is you will pick an interval. Okay, let us say the interval is t is equal to 0 to t is equal to 10. Okay, so you have this interval 0, 10. Okay, now how do you define quadratic variation? Okay, so it is defined as sum of squares of differences. Okay, 2. Okay, so let us say you have divided it into 10 parts, 10 equal parts. Okay, so 2 into 1 square minus 0 square. Okay, and plus 2 into 2 square minus 1 square, right? And you add it up. Okay, so this will be called as quadratic variation of a continuous function. Okay, now you keep your intervals, you will keep making your intervals smaller and smaller. Okay, the smaller you keep making, this quadratic variation for any continuous, I mean continuous functions generally, okay, it tends to 0. Okay, whereas for Brownian motion, the quadratic variation tends to t, right? So this is difference between regular deterministic functions and probabilistic functions. I hope everyone followed the algorithm or logic for calculation of quadratic variation for a deterministic function 2t square, because our next assignment question is based on this. If you have any doubts, you can ask here. Okay, so assignment 2, right? Question 2, right? The question is, write a Python code to verify that quadratic variation of Brownian motion in limit, okay, as del t tends to 0, okay, the quadratic variation tends to t. I hope everybody got this question. You can ask in case of any doubts. Okay. So far, so good. Any questions here? Wiener process. quadratic variations.
So here, how do we exactly quantify that del t tends to 0? Like, do we take some kind of a randomized variable, let's say 0.001, and then
Yeah.
go
So you can choose some discrete steps, right?
Okay.
You can choose your time for your Wiener process, right? So you can simulate a Wiener process between 0 to 1. And then you can first divide it into 10 equal steps. Okay, so 0 to 0.1 to 0.2 to 0.3, so on up to 1. Okay, then you can increase your number of steps. Okay, you can make it 100. Okay, then your smallest step is 0.01. Then you can make it further smaller. Okay, make it to 1000. Okay, and so 0.001 is your smallest step. Okay, so you have to take square of differences of, you know, so you will take w at 0.001 minus w at 0 square plus w at 0.002 minus w at 0.001 square. Okay, and you sum it up, and this should add up to your capital T. Capital T is 1, correct? So if it adds up, only then you can say that, okay, quadratic variation exists and it tends to limit to 1, I mean T, okay, for whatever time it is chosen.
Okay.
Okay, so we are going to move to our next topic, which is, differential equations. Okay. So let us start with some few simple concepts, and then we'll go to some differentiation and all of that. Okay. So let us say I have 100 rupees to invest today. Okay. If I invest it for time t is equal to 1 year, right? And if I invest it at a rate of interest of, let us say, 5%. Okay. So can someone tell me the formula for the final amount? Okay. Which is called as, principal plus interest. Okay, assume simple interest. So your formula will be, okay, P, okay, into 1 plus R into T. Correct? Now, so for sake of simplicity, right, if I take T is equal to 1, right, then our equation becomes FV is equal to PV into 1 plus R, correct? Therefore, our PV is equal to FV divided by 1 plus R, right? Now, let us say you have a series of cash flows. Okay, so you have series of cash flows you're going to receive at different points in time in future. T is equal to 0, T is equal to 1, T is equal to 2, so on, right? And T is equal to N, right? So let us say here you are going to receive C rupees, right? Here you are going to receive C rupees, and the same up to here, correct? So can someone tell me, what is present value of this C? by using these relations. Hello? I think this should be easy, right? At a future time, if you are going to receive C, what is the present value of that? Only this C.
By 1 plus R?
Yes. So for this C, right, it is C by 1 plus R. For this C, it is C by 1 plus R square, right? And similarly for this C, it is C by 1 plus R to the power N. You have to always remember that you can add money at same time instant. Okay, if you are going to receive a cash flow at t equal to 1, okay, so 100 rupees at t equal to 1 is not equal to 100 rupees at t equal to 0. Similarly, 100 rupees at t equal to 2 is not equal to 100 rupees at t equal to 1 or t equal to 0. Okay, all are different numbers. Okay, for example, you cannot add 1 kg plus 1 meter. You cannot add it, right? Both are different units. Similarly, 100 rupee at different point in time, okay, are different rupees. Okay, you can't add it up in that sense. Okay, so you should bring everything to the same time instant. Okay, and it's not necessary to bring it back to 0. Okay, you can bring whatever is at 0 to t1. Okay, everything at t1, t3 to t1, everything to t1, and then add it up. Okay, so you can add money which is at the same instant of time and not at different instants of time, right? So just for the sake of visualization, but let us go back to our equation, right? So what is, what is present value of these cash flows? Okay, you're going to receive C here, up to here. Okay, so present value, right? Value at time t is equal to 0 is, okay, C divided by 1 plus R, C divided by 1 plus R square, plus so on, divided by C divided by 1 plus R to the power N. Okay, now let me give you an example of this, right? What happens is if you take a loan, okay, I don't know, some of you might have taken some loan, okay, maybe education loan, housing loan, whatever, right? So at loan, okay, you are given a loan of whatever, okay, let us say 1,000 rupees, okay, and then you're charged an EMI, okay, so EMI stays same throughout the period of the loan, correct? So this is a representative of that same EMIs, okay, but money at different points in time cannot be added up, right, as we have learned. So all needs to be brought back to present value, right? So we are bringing this EMI to present value, this EMI to present value, and all of that. When you add all of that up, that should be equal to the amount of loan which was given to you. Okay, your EMI may be 20 rupees, 30 rupees, whatever. Okay, so 30 rupees upon 1 plus R to the power 1, and so on, up to if it is a 5-year loan, right? So 1 month, right? So 1 by 12 and all, and 1 plus R, okay, up to 5 years. Okay, so this should be equal to your 1,000 rupees, right? So anybody has any questions so far? If no questions, we can continue from here. So as you can see, this is a geometric series, right? What I can do is I can take C common, sorry, yeah, C common, or even 1 plus R common, and then you can have 1 plus 1 by 1 plus R. So this is geometric series, right? And if you solve for it, okay, you will end up with this kind of an equation. Okay, so annuity is essentially it is called as an annuity product, right? So A refers to the present value of the cash flows that is given by C into 1 minus 1 plus R to the power n minus n, right, divided by R, right? Any questions so far? Hello?
No, sir.
So
I think
now
it's too many topics for today.
yes, it happens because we are covering most things on weekends, right? So
Yeah.
but what will happen is if you zoom out and see, right? I mean, given that you're grasping it for the first time, right? It looks like overwhelming. But if you zoom out, right, you will see that we have not yet covered much, even yesterday or today, okay, for that matter. Okay. So what I mean, the example which I have picked up, okay, for of annuity is for a reason, okay. We are going to discuss partial differential equations, okay. You must have studied partial differential equations in various contexts, in terms of physics, in terms of a lot of other things, okay. I deliberately chose an example from finance so that you understand that what is the intuition behind partial differential equations, okay. So A, okay, is a function of what? What all are variables on the right side? Go ahead.
R.
A is a function of
Small r.
small r, then
N, small n.
small n, and C,
C.
right? So what can happen is your A can change due to change in either of these three, correct? It can change due to change in R, change in N, or change in C, okay? Now let us see how that changes, okay? So total change in R, total change in A will be equal to partial change in A due to R into dr plus change in A with respect to N into dN, okay, change in A with respect to C into dC, correct? So I think I had a visualization here, okay. This is how your for example, if you consider only two variables R and N, right, and then you have A, right? So your A is going to change with respect to, you can move along the direction of R, right? You can change R slowly, right? So you can change R, you can take this is R1, this is R2, keep everything else same, right? And if you just change the interest rate, your A will change. So total change in A due to R is whatever is the derivative at this point. Okay, this is the derivative, okay, multiplied by total change, which is R2 minus R1. Similarly, you will have a different derivative here, right? And so on and so forth, right? So So these are all the possibilities which are taken into consideration. Okay. So if you were to differentiate A with respect to R, right, then okay, you'll end up with something like, sorry, I'm not able to rub it. Yeah. So if you differentiate A with respect to R, right, roughly this is what you will end up with, right? So dou A by dou R will be this, then dou A by dou N will be this, and dou A by dou C will be this, right? I think C is easy because you just differentiate here. With respect to R, it's not that straightforward, okay, because if you are going to differentiate it with respect to R, it is present in both numerator and denominator, right? So you have to use the UV rule, right? So differentiation of a function of form U by V is given by VDU minus UDV by V square, right? And if you simplify it, okay, where okay, U is okay 1 minus 1 plus R to the power minus N, okay, V is equal to R, and then if you simplify it, okay, then you end up with this, okay. Similarly, if you differentiate with respect to N, okay, so here N is present only in the numerator, correct? So for that you require that what is differentiation of functional form A to the power X? Can someone tell me this? What is differentiation of A to the power X? If you remember, or even if you don't, you can just quickly do it, right? So if y is equal to 8 to the power x, then log y is equal to x log a, okay, then differentiate it, okay, so 1 by y dy, okay, is equal to dx log a, okay, so dy by dx is equal to y log a, and y itself was a to the power x, correct? So differentiation of a to the power x is equal to a to the power x log a, right? So we can use this property and differentiate a with respect to n, right, which will give you this, something like this. And when you differentiate d with respect to c, that is straightforward, right? So c just cancels out and whatever is left is that derivative. Okay, so I hope everybody has followed. So we are just doing a refresher of partial derivatives, right? So total change in a function is partial change with respect to the smaller changes, and if you add it up, then you get the total derivative, right? So any questions here? This brings us to the final assignment question, right? Of sorry, assignment 2, question number 3. Okay, the question is, verify this, okay, verify that dA is equal to dou A by dou R into dr plus dou A by dou N into dN plus dou A by dou C into dC. where A is given by this equation. Okay, how you can do it? Okay, so let us say you start with initial vector of C is equal to 100, rate is equal to 5%. Okay, and N is equal to 20, let's say years, right? So DA, right, where so our first vector is this V1, okay, and V2 is equal to, so if I change it this to 110, if I change rate to 5.5%, and if I change N to 18 years, okay, then what is my DA? Okay, the left hand side of the equation you can calculate as like this in Python code, that calculate A with vector 1 values, okay, with vector 2 values, and calculate A with vector 1 values. You take this difference. This is the left hand side. Right hand side, what you can do is you can numerically or computationally calculate the derivative as in Python code. Okay, so you take partial change in A with respect to R. Okay, so keep everything else same. Okay, so V1, okay, for R is keep everything else same and change rate of interest by small change, and is equal to 20 years, right? So dou A by dou R is equal to calculate A at V1, okay, and take V1 R, okay, and take A at V1. If you take this difference, this is this, and dr is total change. Total change is, okay, 5.5% minus 5%. Okay, and similarly you can do iterations for the others, okay, and verify that total change in A is sum of partial changes in individual variables multiplied by respective change in total variables. Okay, so with that we stop. Stop in terms of our teaching, the kind of content. Okay, so what I'll do is we have 15 minutes, right? So I'll just refresh what we have covered so far today. We started today's day with Markov process, Martingales, and so from random walk we define what is a Markov process. We define what is a Martingale, right? We define what is a no-arbitrage. Okay, what is a no-arbitrage condition? Then what is fundamental theorem of asset pricing? Okay, and we define, what's a why do we require a p-probability measure and a q-probability measure? Okay, why is q necessary? Then expectation under q of an asset price is the same asset price. This is important for no arbitrage condition. Okay, and so on and so forth. So we had our basic building blocks of, of what is a Martingale process, And why is it important to have a probability measure such that the evolution of stochastic process is a martingale? Okay, and that leads to a no arbitrage argument, and no arbitrage is fundamental for pricing of derivatives as per the fundamental theorem of asset pricing. If only this exists, then you can price derivatives. If this does not exist, then you'll have multiple price of the same thing and you don't know which is right and which is wrong, and that will lead to arbitrages. Okay, so at a very high level, that is what we saw. Then we had Wiener process, right? So Wiener process, we saw what is definition of a Brownian motion, right? That it starts from zero, it is continuous, right? All its increments are independent. Okay, WT is not independent of WS. WT minus WS is independent, okay, of what happened earlier. And WT minus WS is normally distributed with zero mean and T minus S variance and so on and so forth. Okay. Then we saw what is quadratic variation of a Brownian motion, right? So we saw that squared of changes of Wiener process, when you add it up, it sums up to T. Okay, this, okay, and that is why you know, dw square adds up to dt. Okay, which is also one of our assignment questions. So assignment question number 2, which is to write a Python code to verify that dw square sums up to dt. Okay, and the third thing which we saw was what is the meaning of a partial differential equation. Okay, so partial differential equations tells us that if there is a function, okay, which is dependent on many independent variables, okay, so the total change of that function is partial sum of subparts of the variables where it is derived from. Okay, and this is going to be we are going to connect all the things. We are going to connect what is quadratic variation. We are going to connect that with partial differential equations and Wiener processes. Okay, to come up with a simple rule for how to differentiate a stochastic process which is dependent on a Wiener process. Okay, so that is the foundation for the next step, which is Ito calculus. So Ito calculus, we are going to define how do we define derivative in probabilistic functions and not on the deterministic. So we are aware of how do we define our derivatives on deterministic function. Now we are going to define derivatives on probabilistic functions. Okay, so that pretty much brings us to the end of our third, second session. So at the end of our first week, right, we have covered all the basics which are required in the field of QF, okay, to start building on it in terms of pricing of derivatives and so on and so forth. Okay, so any questions so far? I think what happens is when you do these assignments, right, and when you solve try to do some things on your own, you'd be able to understand a few concepts, and that might possibly lead to a few more questions. So I understand that yes, this is overwhelming and this is a lot of content, right? But like I said, we have not even scratched the surface, right? And having all these course in having all these concepts in a 4-week course, I'm just like I said, I have just covered the basics, right? There are a lot of things which I have still left out, right? We have left out complete markets, arrow securities, you know, state prices, densities, and all of that. Okay, we are just taking very simplest high level concepts of whatever is going to be relevant and important for us in terms of QF and pricing derivatives, right? So any questions so far? Any comments?
So once we study on our own, and if we are having any doubts during the course or even after the course,
Yeah.
you will be active on the group, no sir?
Yes, I'll be completely available. My suggestion is go through the notes, okay? Go through the videos, okay? It's not possible to digest everything at one go, right? But we have our availability of interaction only on weekends, okay? It does not mean that you should learn only while you are in the session, right? You can pick any derivation, any concept, whatever we have seen in our lecture, right? And you can go back and think on your own, right? If I have to do something with a winner process, how am I going to do it? Okay. If I'm, what does it mean by no arbitrage argument? I started with an example of starting a stock price with 100, going to 105, 102. You can try out different example. Okay, you start with 100, go to 99 and 98. Okay, see what happens. What no arbitrage argument you would build there and all of that. Okay, the more you build your own examples out of your own experience, right, you are going to go deeper into understanding of the concept. Okay, we did a symmetric random walk. You can do a different random walk. Okay, different probabilities, different going up and down. Okay, and try to build it on yourself, okay, which is why we have assignments. Okay, so those assignments will likely provide the clarity which you're looking for. Okay, we will have sessions on Wednesdays. Okay, in Wednesday I'll walk you through how do you think through an assignment. Okay, in case you have any questions, so my expectation is at least you have tried assignment by that time. You'll have some questions. Okay, this does not work, this is not understandable, okay, that is not making sense, okay, can you redo this part, can you redo that part, okay, and then accordingly we can structure how to do it going forward. Okay, so Wednesday is a good opportunity for us, both of us, to catch up, to be at a common point, right? And for you will have at least 2 days to reflect, okay, what has happened. I think 25th must be a holiday again for you guys, right? I'm not sure, but that should have, you should have another 1 day to reflect on what has happened, to digest it, okay, and then come up with a set of framework in mind and in any questions if you have. So on a lighter note, okay, I think you must have all heard of this uh, it's better to be, what do they say, it's better to be king of one trade
Then loser
right,
of all trades.
than jack of all,
Yeah, okay.
right? This
It's,
is the
it's
proper,
better to be master of one.
correct. It is better to be master of one trade instead of being novice at all, right? So if you have many trades, correct, so this is how a guy who is, I mean, he does not have depth of understanding, right? So he just has limited depth, okay, but he has visibility over a lot of subjects. So these are many subjects, okay, but he has limited depth, correct, versus what they say is have limited subjects, okay, but whatever you have, you should have depth in it, correct. Unfortunately, quant finance is about having all subjects and having depths in everything.
Which is what makes it more complicated.
Yes. If you expected quant finance to be, simple and easy, right, with very few concepts and thing, what would have happened is barriers to entry would have been low, right? Everybody and anybody would have aspired to be in field of quant finance, and everybody would have, okay, excelled in it and all. Okay, so this is quant finance. Okay, if you're talking about mathematics, okay, what mathematics you have learned so far is not sufficient to cover quant finance. Okay, all the effort which we have put in so far is only to build the building block of Ito calculus, and everything. So we have built up to here, right? So this is Ito calculus, right? Everything above this is what we require for our course, Quant Finance. Okay, that's the way the course is. Okay, if you have knowledge of finance, right, you have done CA, CFA and all of that. Okay, you must have seen balance sheets and profit loss statements and all of that. Okay, and you must have seen definitions on call and put options. Okay, call is a right to buy a contract and all of that. Put is right but not obligation and all of that. Okay, that is just the beginning of Quant Finance. Okay, on top of that, when you build, okay, that's when you get Quant Finance. Okay, so you must have seen codings, right? So here the coding has a very different challenge, as you must have understood by now. Okay, you in coding, right, if you take any course, right, you have lead codes and you have kegels and you have all these exercises, right? There the hard part is about knowing syntaxes, right, writing clean codes, correct, then defining your variable names good, right, and so that it is readable, documentation of your code, right, uh, comments on your code and all should be written well. So those are the parts which will be focused on, correct. But when you come in Quant Finance, coding has a very different meaning. The meaning of coding in Quant Finance is you need to understand the workings which are happening behind the scenes, correct. You would be able to solve this coding assignment with very limited knowledge of coding, right? Of that, of just couple of for loops and all of that. Okay, but to be able to execute or solve this assignment, okay, you need to understand what is a partial derivative. Okay, here still I have given most of the hints. Okay, but when you go as a quant developer role, okay, there you will be given a mathematical equation, you will be given just this. Okay, and it is your headache to figure out whether I'm going to go with discrete of 0.005 or whatever, right? This all figuring out is your headache, right? But when you write the final code, okay, if this number turns out to be 20 rupees, right, this number has to turn out to be 20 rupees. That's all you know. How to do in between, what should happen at the back end, that is what a programmer has to sit and think. To be able to do that, he has to be able to understand what is happening here, right? Then add it up, then why it is matching, why it is not matching and all of that, right? So coding, right, you start here. It has a very different challenge in QF. Okay, if you know basic loops and all of that, that is kind of not sufficient. Okay, you need to know what is happening at the back end, what discretization, what simulation, okay, what probability measure. Once you know these things, researcher will only tell you the final result which you need to implement in library, Python library. Okay, for example, he says that use binomial pricing. Okay, build a Python library for me. Okay, build a Python library to price an option using binomial tree. Okay, and at most what he will do is that researcher, he will give one Excel example of it. Okay, he'll price and so one option, so that whatever output of your code, you can cross check with that result and match that it is matching or not. But everything else, okay, he will just tell the algorithm. Okay, start with step 1. Okay, do this, step 2, do this and all. But in terms of code, it is the coder who will sit and think how to do it. Okay, so just like that, I have mentioned to you all the steps what you need to do, okay, to be able to generate an answer. But how you need to do it in code, it's up for you to think. Okay, so that is why quant finance is about being king of all trades. Okay, only when you're king of all trades, that's when you are elementarily ready for your, what I can say, an elementary level job or an entry level job in QF. Once you have all of this, then you have entry level job.
And how long this is going to take, at least, to get basics right and get entry, at least minimum time?
See, it is about practice. Okay, it's about practice and everybody's grasp, right? Everybody understands things differently, right? It's about your pace. Okay, how much time you can give. You're doing a full-time course, right? You're not sitting at home and doing nothing, right? If you're sitting at home doing nothing and you're doing only this, maybe it takes 1 year to 2 years to grasp all of this. You have a full-time study going on in your college, right? You have your coursework to complete, assignments to complete, and on top of that, whatever how much time is available, that depends on each person, right? Some of them, some people may be really good at their coursework, so they don't need to spend time there, so they can spend all their time here, so they can pick these fundamentals easily. Okay, and some of them may not even have time in their coursework. Okay, so they are struggling there, so expecting them to pick this up is daunting, right? Because like I said, this is not trivial. If anything, this is as good as a full-fledged course, right? So that is why you will see any course in quant finance is introduced as a master's only course. All
Right.
over the world, you will never see QF being introduced as a graduate course, undergrad course. Okay,
So do you
why?
think that World Quant University is offering a financial engineering course, right? Do you think that is good?
Yes. No. See, everything is good. Okay, everything is good, but like I said, what if whatever I covered, okay, if you feel, what is your background? You're from engineering, right?
I'm from engineering and yeah, I have an MBA also. I'm currently working actually.
Okay. See, if you are feeling it daunting, right? Just imagine
And I
even if
worked in equity research for 3 years.
okay, okay. So if someone is coming from 12th background, okay, just imagine how daunting that guy is going to feel all of this, right? For the sake of offering, this course can be offered by WorldCont University. They can say that even if you have, even graduation is not required, right? Class 12 is sufficient. Okay, but you need to be able to sit, think, grasp, absorb all these concepts, okay, and build on top of this, right? So it takes effort. It is about how much effort you put into it. So I know about WorldCon course, and you can also take that up, and also that's a good option in case. So I think it's for free, right?
Yeah,
Uh,
it's for free.
but but yes, so do take it up. Okay, so again, my suggestion to all the people who are attending these courses, right? Do it if one, you're interested in it, and two, you feel you're going to make your career in it. Okay, otherwise it is putting in a lot of effort. Okay, for, unless you make the use this to make money as a trader, as whatever, as risk management professional or anyone, otherwise this is very huge in terms of expanse to learn, right? So it's not trivial, and it is effort taking.
So how easy or challenging you find to make money using these concepts in the market?
Like I said, right, these concepts are built on the belief that you can hedge well. So these are about ensuring that there is a security one. Okay, let me give, on again on a lighter note, let me give a different example. Okay, let me explain what do you mean by hedge and arbitrage. Okay, maybe I should have done this earlier also.
And also, I
So
wanted to ask you one more question. Like, we have already a lot of fund managers, portfolio managers who have their CFA credentials and all that. So,
correct.
what's the, and even they are making money. What's the difference between fund manager who has learned all of this and fund manager who's done CFA and still making, both are making money?
Yes. Okay, so
So
I'll
if
explain that.
yeah, if somebody is making equal amount of money, then the person who is not studying all of this, putting all this effort, is better
Yes.
off, you know.
Yes, like I said, right, you should be learning this if you're planning to use this in your day-to-day life, in whatever
Mhm.
sense. Okay, as an employee, as a professional, or as fund manager or whoever, right? Now, the question which you asked is, there are two guys, okay, one which has knowledge of understanding of finance, right?
Mhm.
financial statements, right? You have balance sheets, income statements, right? And you have other things, right? Cash flow statements, fundamental analysis, right? You have all these tools. Then there is a guy who has these tools, right? So what is the difference between this guy making a money and this guy making a money? Okay. Or you're saying there is a guy who knows this, okay, A plus B, right?
Yeah, plus
And there is
QF.
a guy who only knows A, right? Then what is the advantage for this guy, right, who is doing A plus B, right, versus A if they are making same amount of money? The only thing which you're missing here is you can make same amount of money doing B only, right? So I can make money B without any of this, which is what we are going to see at a later stage, right? Like I said, there are three ways to make money. There is fundamental analysis, technical analysis, and quantitative analysis. So we are going to see how money can be made using quant without knowing all of this, right? So this class, okay, is hedge funds. Okay, this class is mutual funds, because mutual funds are not allowed in derivatives market, shorting is not allowed, and all of that. Okay, I have not practically seen this, okay, because as you can understand, this itself is a full-time course, CFA / MBA, right? This is a full-time course, 2+ years.
Yeah.
And as you said, if you assuming you're making same amount of money, then you're better off doing one of these, right? Doing both of these doesn't make sense. At the same time, if you're doing both of these and if you have enough resources, right, then you can use this as complementary, right? What you can do is you can find a strategy using this analysis, correct? And you can find the strategy and you can verify that strategy using this analysis. Okay, so you can make same amount of money, but maybe with lower amount of risk.
Yeah.
So this is risk 1, this is risk 2. So you can improve your Sharpe ratio in that sense, right? So making money is not only about making money, it is about for what unit of risk you have made that money. If you can make the same money at lower amount of risk, then maybe you're better off taking lower amount of risk.
But even like in the people in the category A, so let's take Warren Buffett, right? I believe he's in the category A.
Yes.
So he doesn't know anything of quant finance, but he still invests a lot of money without taking much risk. So in a way, he is also using these concepts.
No, but how do you know what is his risk? I'm not saying that he's necessarily worse off. Okay. Without using B, you can still find minimum risk portfolio. I mean, possibly, okay, because okay, this is an optimization problem. Okay, you want to find a low risk portfolio, correct?
Yeah.
If you start here, okay, you are going to find this as the lowest risk portfolio, correct?
Maybe, yeah.
Okay, but if you start here, okay, you will find that this is a low risk thing, okay, and maybe you will stop here. So this is local minima. This is global minima.
Yeah.
Okay, using A plus B, in my opinion, or any other method, okay, maybe machine learning on top of this, okay, the more number of methods you add to the analysis, the guarantee that you will reach to global minima, okay, it improves the odds of reaching the global minima. Okay, are we capable of replicating Warren Buffett, okay, in terms of lowest risk by studying only this is the question. May not be. Maybe it is his experience that he has learned, which fills in for this, which we can't borrow from him, right? But if we have ML or any other technique which attests our intuition, okay, it says that your intuition is right. Okay, if you do analysis using 3 different ways and it points to the same security, right, it definitely means that that security is good, correct? But if one analysis points to this security and 2 of them says that this is bad, at least you will doubt this, right? And you will start searching a new security such that all 3 of them converge to saying that this is a good time, good security to invest. So these are all complementary skills. If anything, this will help you finding something better. If not, okay, someone, okay, so you are asking, right? Some guy who is doing only A, right? It does not mean that guy will never reach this global minima. Luckily, he can reach. Okay, if he starts from here, he is going to reach here. Okay, but we are trying to take an adverse situation, right? That randomly you are here, correct? And you don't even know where the global minima is and how to reach there. Then my point is, if you use more number of things, you will keep persisting through this bad phase so that you reach to this global minima. Okay.
At least we know what we are going through in the B situation.
Yes.
I mean, even things like, Ben Graham talks about value investing and margin of safety, right? So in a way, like B is kind of verifying that.
Yes.
Okay.
Okay. Any other questions from anyone?
Hello,
Yes.
am I audible?
Yes.
Sir, basically, I would like to ask that how would you like to distinguish between quantitative economics and quantitative finance as a major if like to be pursued further to build a career into
I think
with different portfolio?
quantitative economics. Okay. Incidentally, there was nothing like quant finance before Black-Scholes invented the famous equation, right? So essentially, Scholes and all were essentially economists. Okay, just to add that as tidbit. But quantitative economics, okay, is, I think it has more parts of so it is empirical. It has a lot of empirical analysis, right? So using the data, for example, GDP, so micro and macroeconomic data, and using that to assess the impact of that on financial assets and all of that. Okay. So this relies on a lot of historical data analysis, historical statistical analysis. So this again comes largely under p-probability measure, actual probabilities and all of that. And this will lead to, if some person has taken a loan, okay, what is his probability of default if inflation goes up by 10%, unemployment goes up by 10%? If you have to answer these kind of questions, then quant economics is the right guy who would be able to answer it. He'd be able to explain why certain microeconomic phenomena reflect in a certain way in financial assets. Okay, whereas QF will be about specific individual security. QF will be about how to price a security, how to price a mortgage-backed security, how to price an Asian option, how to price or how to manage the risk for a digital option. I have digital option on my books. How do I manage that risk? What are various option strategies if I'm bullish? What are various combination of strategies if I think volatility will increase, but neither I don't know where it'll go up or down, but it will be more volatile. So what should I do, right? So that's where QF comes in to picture.
All right. So is it like financial engineering is a subset to economics or quant finance, or is it like these
No,
are
so
the subsets?
yeah, you can consider QF as a very niche application of QE. Okay, but as you have seen, this in itself is very specialized, right? If you know QE, it does not directly mean that you will know QF. If you want to be in QF, you have to specifically study QF. So if so, for example, ML. So you have AI, right? ML is a subset of AI, correct? But learning AI does not in itself mean that you will know ML, because ML in itself is very vast and very big, right? So if you want to study ML, you should study ML. If you want to study AI separately and specifically, you should study AI. But don't assume that if you know AI, by default, you will know ML and everything within ML.
So in the long run, how is the industry that perceives both the course as someone moving for higher studies in these domains?
So QF is very popular. Okay, QE in terms of numbers, it's not that popular. Okay, it's as far as I know. Okay, because you don't. So economists, right? Where quantitative economists, in terms of decision making, have role only in context of certain regulations. For example, you have CCAR and all of that, subset of that. But you have a much bigger industry of based on derivatives. You have few $1 trillion industry which is based on derivatives. Derivatives are what should I say, globally understood, studied, traded. So in any market you go, right, you will have globally symmetric or uniform definitions of all products. So the derivatives market is much bigger. So all the ecosystem around it, trading, hedging, risk management. So you have a very well established ecosystem around it. QE largely goes into the domain of risk management. Okay, and how do you manage risk for various macroeconomic variables? Risk management is generally seen as a cost center and not a revenue center. And I think that's a cost center is not at the forefront of the focus or at the center of things. Okay.
Right.
There are many good
So,
QE courses. There are many good QE courses. So I think London School of Economics and all, they offer QE, right? Quantitative economics.
right.
And I think even in India, we do have a few good masters in QE. Maybe I think it's there in BITS Pilani. I'm not sure. But MFE, despite being more niche than QE, right? It's very specifically and far more developed. For example, in AI, right, we have most roles which require ML, right? So ML, despite the fact being it's a one part of AI, it is more dominant in terms of job availability in the market and demand and whatever you would like to call it.
So,
So,
in terms of making money, who makes more, QF or QE, guys?
Uh, like I said, it depends on many things, but if I were to take average, right, on an average, this is my opinion again. On an average, in my opinion, QF should make more than QE. Okay. That's like asking which branch of engineering earns more money, right? Whether it is mechanical, civil, electrical. Okay. So I think if that is the question, then your answer is by default on an average. It depends on students also, right? And opportunities. But on an average, CS guy should be making more money, right? That's what statistic tells us historically. But again, it is just, I mean, there are exceptions to everything. Then you have recessions and all, right, in CS and all. So there are many factors. But if you want a blunt answer, that's what it looks like.
so, sir, as a someone student like who's planning for undergrad, is it like a more wise decision to go a specific, as I'm like interested in both the domains, and or like go for a general degree and then have a specialized courses or something or certifications kinds of thing?
So your ultimate objective should be to go specific. Okay, your objective should be to go into as much niche as possible. Okay, you should have an expertise where you are the go-to expert for it. Okay, that should be your ultimate goal. But in terms of, depending on whether you said undergrad or postgrad, right? I think undergrad you should be generic. Okay, you should have something of everything to understand what happens. Okay, because if you go to postgrad and you require something of something which you don't know, right, then you need to start from basic. Okay, let me just go a little personal here and let me give my example. I am from mechanical engineering background. Okay, I did not have any coding experience, zero coding experience, zero exposure to probability and statistics. Okay, and zero exposure to finance to begin with. Okay, so people, while I was doing MBA, people who were from bachelor of statistics background and all of that, they already had statistics in place. Okay, so they had to just build the other two concepts. People from CSE background had started already have coding as a background, right? So they have to just worry about maths and the other things, finance, right? And people who have done BBA and all, they already know at least a bit of finance, right? Or at least from CA, CFA background, so they already know financial concepts. They have to worry about the other two. Okay, so if I were to come to masters, okay, by in my undergrad, if I had some electives on economics or something, right, on coding, if I would have taken those, my life would have been easier, right? Then I would have focused more on the niche subjects in my masters. Okay, so if you're planning to do masters, so within your masters, choose a very specialized subject. Within your undergrad, try to expand out as much as possible, so that you have a basic of everything, so that you can build on top of that as and when required.
All right, sir. So would it be wise to come to conclusion that a bachelor's in maths or statistics very would yield higher returns than a bachelor in economics while building a career in finance?
Good question. I think bachelor of maths will be more useful. I mean, very useful in a lot of other things as well. Okay, even if at later point in time you choose to go to AI, quantum computing, anywhere else. Okay, maths is going to come to your rescue again and again. Okay, economics means you are restricting yourself to economics, right? So your next selections are going to be allied to the subject of economics if you start with economics. So yes, my suggestion, if you want to be more generalized, would be to go to maths.
Even as the BTECs and degrees put alike.
No, I didn't get that last point.
No, I said like even when the BTECs, all the technological degrees put alike to the B maths and B stats.
So you're asking whether you should go for B maths or B stats or to tech degrees between these
Right,
two.
because they do not, the tech degrees do not like take a lot of mathematical uh, curriculum into their coursework.
No, in now if you're comparing two different things, right? Now if you're comparing about BTech degrees versus bachelor in maths, right? The difference I would say is you would have at least a couple of more things in your BTech degrees. For example, you would have coding experience and all. Okay, in BTech degrees on top of maths. Okay, maths which you're learning in BTech degree may not be of the same depth as that of maths of uh, bachelor of maths. Okay, but still in terms of width, right? In undergrad, you're trying to go for width. So width will come from your bachelor of technology, right? By technology, I understand anything of CS background or mechanical, electrical, or from something like that. If you're asking between BTech of economics, okay, and bachelor of maths, then I'll suggest bachelor of maths.
No, actually, there are few universities offering bachelors of technology in mathematics only.
Okay.
And there are some other universities stating just having bachelor's of maths confined to the curriculum.
Yeah, so the former one makes sense then. In your undergrad, you should spread out. You should go to technology/maths in your bachelor's.
All right, sir. Thank you.
In your bachelor's, you should spread out. In your master's, you should choose and build your competency or expertise.
And that would certainly be more on yielding results, higher ends, right?
Yes.
Giving very good
See,
depth on.
again, all of these help you in first up to first 4 to 5 years of your job. Okay. Beyond that, whatever you pick on your job, experience and all, then that starts getting important. So your investment is only worth up to first 3 to 5 years of your job. Beyond that, you have to start learning things on your job and start picking up new things and skills, right? So that starts getting more dominant.
And so similarly, I do have a follow-up question on that.
Yeah.
Like if we picked up something of more mathematical heavy course load in the undergrad, and
Mm-hmm.
for the postgrad as masters, we are
Mm-hmm.
going into a subfield. Is it? I think it won't be a very nice idea to get an MBA rather going for an MS in um, something of these quants, right?
So you're asking between MBA for quant versus MS for quant, right?
Right, right. It's more like
So if
research heavy oriented.
so again, it depends on your objectives, right? If you have a research kind of roles, right? Quant research, quant development kind of roles, then QF makes more sense or MS makes more sense. If you have a business facing role, right? So sales, marketing, and all of that, right? Or so on those lines, then MBA, which has more business orientation, right? That makes more sense. So don't assume that everybody sits and derives something or the other in QF field, or everybody sits and writes the code. Okay, there are sales guys. You need to go and talk to clients, explain them something new. Okay, not every client is sophisticated. You need to talk to them in layman terms. You need to break it down. You need to explain in simple words. Okay, if something goes up, then this derivative will help you do this. This will help you do that. Okay, so there are a lot of other roles, okay, which are not directly only quant research or quant dev. Okay, so you have business roles, you have business executives, you have sales and all of that. Okay, so those have a lot more relevance in MBA kind of a degree in your masters. So how to grow business in derivatives, right? How do I pitch to more clients and all of that. Okay, so that has a different skill or competency required. That will also require these basics, but then maybe stochastical and not, it's not that very important, and you need to not go that very deep in maths.
Sir, you have learned all these things from, I mean, after your MBA, right?
So yes, what you are seeing, no, currently whatever I'm teaching to you, okay,
Mhm.
I have learned it only in MBA, in my only 2 years of course. Okay, that too not even 2 years, because first year of MBA general, right? You have to learn everything, operations research and a lot of other things, supply chain management and all. What I am teaching to you was covered in only 1 year.
So
Okay,
you have done MBA in quant finance.
financial engineering, yes, from IFM Chennai. So whatever I'm teaching to you now, everything, quadratic variation, Ito's calculus, and what we are going to study right up to week 4. Okay, all of that is culmination of only 1 year of teaching, learning. Okay, and maybe a little bit of FRM, but anything which is based on my experience, which I learned a lot. Okay, I have total 6 years of experience after my MBA. I've learned a lot, and that forms chunk of my understanding and knowledge. Whatever is there in that 6 years, that forms the chunk of understanding and knowledge. Okay, so that's a separate topic, and that has a separate curriculum. Okay, so I keep talking to people, okay, even the ones who have gone to US and all. So if they have some interviews lined up, okay, in US, they do get in touch with me. They do ask how this works, how that works, and I help them to come up to speed with that interview, how to prepare for an interview. I mean, I'm talking about laterals, okay, who have 2 years of experience, 4 years of experience. I help them out there in US as well, okay, and they too also say that in their experience, what is being taught even in US for MS courses and MFE courses, right? They have a lot of theoretical and abstract concepts, but beyond that also there is a lot of big maths and framework which sits outside that framework, which you need to study and understand as a part of your job experience. Okay. So if you need to get a job in US in the field of QF, I think MFE is important. Whether or not that course fully gives you all skills and all the abilities, that is important. Okay, you will not simply get any entry into US. If you want to sit in India and crack a QF role, okay, then you have certifications of CQF and all of that, or you can do few colleges. I think IIT Kharagpur offers it. Then I think Chennai Mathematical Institute offers it, IFMR offers it, and a lot of other people have now slowly started offering it. Okay,
But can we do that working, studying part-time?
Like I said, it depends on you, right? I did my FRM fully part-time. Okay, so I had 10 plus hours of daily full-time job. Okay, and post that whatever studying and learning I was doing. Okay, so you can do this full-time learning your own self. Okay, but okay, my point is my problem with doing it on your own self is just what I just explained. Okay, if you pick any concept, okay, if you pick a simple concept of this fundamental theorem of asset pricing, most literature or content which is available on Google, right, is very abstract. Okay, how do you start and where do you go, right? I personally speaking, I don't have an answer for this. Okay, because whenever I start learning a concept, I don't like to encounter symbols which I don't understand and skip it and just go ahead. Okay, unless and until I fully understand what is happening, I don't feel confident about reading things going ahead. And every and all material which is available, so as you should understand, this field QF was invented by PhD mathematicians. Okay, so they expect that all basics you know already. Okay, so they will not go into explaining the basics to you in any white paper or anything. See, it directly starts from this. Okay, so there is a Q, so omega F and P. Nobody explained what is omega F and P. Okay, directly there is a word geometric Brownian motion. But how do you define geometric Brownian motion? What is stochastic differential equation for it? What it means and all of that. So anything you start reading, they start with a lot of abstract maths. Okay, for example, this Redon Nicodemus derivative dq by dp. You don't know this, right? What next? So that is why I don't find a simple enough explanation article or anything. Okay, whatever I'm teaching, first I practice it. Okay, I write it down myself in the notes. I make sure that I understand it and I don't have any doubt in that, and only then I bring it onto the table and explain it to you all. Okay, if I don't understand it, I don't explain it. Okay, so whatever you do, you have to reach to that stage where you understand these things. From what source you do it, from what book you do it, it does not matter. Wherever you start from, you reach to a stage that you pick up a concept and you understand it fully. Until you don't understand it, don't leave that concept. If you keep doing this iteratively, then you will eventually you can build on your own. Okay, so this is my only problem with learning it on yourself. Even if you go to MIT courses, right? So if you go to YouTube, right, and MIT courses, MIT course on QF, right? So you will get a lot of this, right? Utility functions and supply demands and all of this. But I have seen all of these courses also, and I feel again they start with the same things, right? Sometimes you have lot of abstract concepts and a lot of things, okay, and it doesn't make sense to you. So that's my problem with it. Okay.
Sir,
Yeah, go ahead.
sir, actually, why I picked up quantitative economics was by seeing these courses actually.
Okay.
Most of them were inspired from the professor you were seeing there.
Right.
He was telling depth about how economics, especially in the health economics and the one above,
Correct.
right? So that's why I was asking because both of them does not see a linkage to me.
Right. In between QF and QE, right?
Right, these courses that you guys showing
Yeah,
there.
yeah. So this is completely different. This is into microeconomics and macroeconomics. Okay, so this is completely different in that sense.
Right, and they do not have any practical uses in the industry, or do they have?
Not true, not true. At least both of them have, but in different context. Okay, like I said, there is a sorry.
Go on.
So for example, if you want, do you want an example of QE, quantitative economics?
Oh, sure, that
This-
helps.
yeah, there is something called as CCAR.
Sir, you said all these concepts will be helpful only like up to 3 years or 5 years of the getting the job, right?
No, what I said was beyond that, you need to build on yourself also.
Huh.
And
But
what will
what
happen
if?
is that you start getting grower bigger than this.
Mhm. But what if I already have 5 years of work experience in business analysis and equity research, and I
Right.
still want to learn this and get into this field?
So you will start as fresher again.
Mhm.
For example, if for 5 years I have been doing mechanical engineering, let us say, right?
Right.
And let's say from tomorrow I want to do coding. I will definitely be treated as fresher only, right? I can't be treated as someone who has 5 years of experience.
But what about my, I mean, salary package? If I'm already at some
In
level.
my opinion, if you are ready to accept a fresher salary package, only then you'd be allowed to enter it.
Mhm.
Okay. See, everything is a compounding investment. Okay. 5 years you have put into equity research. Okay. So, okay, I ask you, okay, there is a guy who is in computer science, okay, who has been working for 5 years, and tomorrow he wants to start equity research. Okay. He claims to have done some certification, CFA, FR, and whatever. Okay. Now you, as a person who has done CFA plus 5 years, okay, are you on the same benchmark as the guy who has done only CFA and who has done
No,
COMSA and trying
I'm
to
at a
enter?
higher level, right?
Yes, higher level of understanding,
Understanding.
experience,
Yeah.
maturity, skills, right? And so both of you don't stand on the same level of maturity and understanding, right? So you cannot be treated at par. And that guy is not ready to take a cut, right? That is why that guy finds difficult to get into your roles. He's not, I mean, more often than not, people are not ready to start. Okay. For example, if I'm doing QF for past 6 years, okay, it does not mean I'm a default entry into ML. If I have to do ML, I have to start as an intern. So let us do certifications and everything, and then start as an intern, and then start from zero again.
But if I'm not looking for a job, if I'm already happy with equity research, let's say, but I want to learn on this on the side so that I want to build something of my own rather than working for someone. I want
Yes.
to, we
Yes,
can
yes,
do it.
yes, you can do that. Like I said, we'll discuss about these strategies. Okay. So what you can do is you can write a code to identify the stocks using QF strategies. Okay. Then you can cross check that with the set of stocks which you have shortlisted as per CFA understanding. Correct. There will be
Right.
a section of stocks that should be technically better quality stocks, right? Than using only your CFA knowledge.
Okay.
I hope that answers, right?
Yes, yes.
So coming back to your question on quantitative economics, right? So there is something called as CCAR. Okay, so large banks have to undergo CCAR and all of that. Okay, so what they have to do is like India has RBI, right? So US has Fed Reserve. So Fed Reserve asks bank every year a simple question. Okay, that if your economic variables deteriorate with to a certain level, right? So there are certain scenarios which is called as baseline adverse and severely adverse, which are told by Fed to banks. Okay, Fed, I mean US equivalent of RBI, right? It says that let us say today's unemployment rate is 2% and inflation is 2%. Okay, and rates are this, interest rates are this. Now assume that 1 year down the line, unemployment goes to 15%, okay, inflation goes to 10%, and this so on and so forth, right? Can you predict what losses you will incur as a bank? Okay, so these scenarios contain numeric values, okay, of macroeconomic indicators describing potential global economic scenarios within the next 2 years into the future. Okay, and then they ask you the questions in baseline, what will be your losses? Then in bad scenarios and severely bad scenarios, what will happen? So this is where a QE guy will likely come in. So there are roles, there are jobs which require QE, okay, and which exist in banks.
But when we come to the organizations other than the banks, majorly corporates, they are heavily dependent on revenue, requires QF, right?
No, not true. I think you are understanding banks as only investment banks. Banks has many business models. You have retail banks, correct? You take deposit from people and give out loan. Then you have wholesale bank. You take deposit from retail people and give to big people for big businesses, right? So there are many kinds of activities within a bank. It's not only investment banking or trading derivatives. That is only one arm of it. Like in cricket, you don't have only batsmen, right? You have batsmen, bowlers, fielders, right? So a lot of things.
That was all from my side. Thank you.
Sure, happy to help.
But
Any other
so one more question, last question.
Yeah, go ahead.
So understand the importance of quant finance and all this, but people who have like Jim Simons and what is it, Citadel, Ken Griffin, right? All these people did not study anything related to quant finance, but they have started somewhere, and now they are applying all these concepts and they're hiring people who knows all this thing.
Yes.
So in a similar way, like being in equity research,
Yes.
like do I can't I also build my own? I mean, whatever I'm doing right now. So using quantitative finance, I want to build on top of what I'm already doing, rather than looking for a job separately in this field.
Yes.
So I can do that, right? How can I do it?
Yes. Like I said, right, we'll discuss that. Okay. This is just the first week. We have few more weeks, and in 1 week we have slotted how to design a strategy for quant finance using only quant finance. Okay. We don't look at any financial data, any historical analysis. I mean, we do historical analysis, but not fundamental analysis, right? So we will come to that point. Okay. And then we'll see how the concepts which we have learned can be used there.
Sure. Yeah. Thank you very much.
Sure. Okay. Any other questions from anyone? No? Okay, so I think we are good to close the call. Yeah. Have a nice weekend, everyone. Bye.